This facility was built in 1973, and it falls under the Ag Experiment Station department. Currently, we have 6 ranges of greenhouses. Each range holds 3 greenhouse bays, making a total of 18 greenhouses. And that gets us about 11,000 square feet of space under glass here. And they call it under glass even though it's polycarb, but they call it under glass. We're staffed with 3 full-time employees out here, myself the manager, Ryan Pendleton, who's our horticulturist, and research associate, Ethan Walter. And we also have 1 part-time, Amy here. And there's currently 18 researchers out here utilizing the greenhouse space from all disciplines, weed science, soils, plant science, entomology. So there's quite a few different disciplines that use this facility. It's not just plant science. So if you guys would like, we'd take a tour around the facility, and if at any time you guys have a question, just shout it out and I'll try to answer best I can. So this area that you guys are in now, this is the North Hall. This consists of all of our offices and lab space. Lab spaces are assigned through the department to the different researchers out here. We start off here at the Pesticide Central Information Board. That's something we take real serious out here, is the use of pesticides to control pests on our plants. We do above and beyond what the EPA has asked us to do. So I do teach a class that I make everyone who uses the facility has to go through a pesticide safety orientation. And none of the pesticides that we do use out here are restricted use. So we don't have to have special certifications to apply those, although we do have those. And any information people want to know about what's applied out here and when it's applied can reference this section here. As far as worker protection standards with the EPA. Behind you here on this side is our facilities map, just kind of lays out the facility, showing the plot space and greenhouse locations. On the south side of the greenhouses, as you'll see outside, that's our dry land area. There's about an acre of dry land that can be used as microplot space for those researchers wanting to do research on dry land. And then also out here to the west, we have about 2 acres of irrigated space. And each one of those plots is watered with overhead watering on ratcheting sprinkler heads. So we can control a little bit about how much water goes out there, but it works in conjunction with the plots next to you. So one researcher plot is sharing a line with the next researcher's plot. So we ask that those plots needing special requirements in water application, that they work together with the other plots adjacent to them, or we'll separate them out a little bit if it's quite a bit different than what people need. We generally put out about 1.5 inches of irrigation water per week, and that seems to be about the norm unless people are studying how much water their plants are using. So then it would be a different type of research, different watering regime. We're going to head over here to the South Hall to where the greenhouses are. And like I said, if you guys have any questions, please feel free to ask. So I'll give you a little bit more information about greenhouse controls and that kind of stuff. And as we work our way down the hall, feel free to poke your head in any of these greenhouses. There's 6 different styles for the 6 different ranges on the setup on how these are set up. 3 of them have hallways that go down the side with greenhouses to the side, and 3 of the ranges are what we call walk-through, where you get a little more space, but everyone has to walk through your greenhouse if you're on the end. So all the controls are Johnson control systems that they use here on campus. These DXs we're able to set high points, low points. We're able to take the temperatures, trend data in the greenhouses, so those that are doing research and need, say, temperature data for their research, we can log that through here back to our main computer. I can also log in remotely from my iPhone or from my computer at home, and I can change set points, or I can get alarms. Everything is set up on alarms, so if a greenhouse gets too hot or too cold, usually about 7 to 10 degrees over what the set point is or under the set point, I will get an alarm and then I respond to those. So 24/7 I'm on call. Gratefully though that the greenhouses tend to stay pretty well controlled. We don't get too many cold alarms in the winter, which is nice. Our biggest problem is trying to cool in the summer. There's 4 cooling stages in each of the greenhouses, starting with ridge vents. That's our first stage. Exhaust fans will then kick on if it needs more cooling. The swamp cooler fans will then kick on, and then water comes in over the swamp cooler pads, and that helps to cool the greenhouses. With the smaller greenhouse bays, it's a lot more difficult to make the temperature more temperate, I guess. because the variation or the microclimates in each one of the corners of the greenhouses where air is not circulating. You might get hot spots off the walls from the sun. So it's a little bit more difficult to cool than heat. Our heating is run in 2 stages. It's a steam heat is our main heat, and modine heaters, which you'll see in these greenhouses, these big heaters that sit up above. That's our secondary heat in case the steam can't catch up. So as a lot of you know, we've hit very cold nights here, and since I've been here, we still haven't lost any plants due to cold. So it's more of a heat thing than the cool thing. What's that? I do not get to see the utility bill. I know that the university does get a great rate on electricity, so we're trying to move people from using high-intensity discharge lights to using an LED lighting system. And you'll notice too in actually this greenhouse right here, these purple lights that you'll see inside is a LED lighting system. And we're saving what the company says is about $5,000 per light over the lifespan of that light versus traditional high-intensity lights. So high-intensity lights be like a lot that you see on street corners. They use high-intensity lights, same lights they use in the greenhouse. So the energy costs are a lot lower here with these LED lights. And you'll notice here as you walk by this greenhouse that the corn that's in this greenhouse looks just as good as the corn that's grown at the end greenhouse with high-intensity lights. We do have growth chambers located throughout the facility. In that hallway behind you there's 4 refrigerator-sized growth chambers, and then we have a few of these smaller ones. All the growth chambers are owned by the researchers themselves, and usually they're kind enough to let people rent them if they've got the space. Yes?
I've got a shovel and a rake and a hoe.
Okay.
You're going way over my head here. How would we utilize all this?
Well, these greenhouses in particular are more for the research, where we bring up the plants. Homeowners, this isn't a retail type of greenhouse like you'd see where they sell plants or plants that you'd grow for your, say for your garden beds or something like that. It's all research out here and funded then by Agriculture Experiment Station. Any other questions? So feel free as we walk down the hall here, and then I'll meet you down at the end. Take a look through some of these greenhouses. If you have any other questions about the equipment or the structure, maybe what experiments might be going on, there are some researchers here that can sure help if you guys have any questions about their research. Other than that, I'll just meet you guys down here at the end. We also have here at the facility a process and drying and harvesting room here. We got 4 new dispatch ovens, which is a company from Germany, and that allows our researchers to bring in their plant material from the field. They can dry it down in these ovens. A lot of research will ask for dry weight, so we got to make sure that there's no moisture in the plants. So depending on the plant type and how much they got, we can let them use these ovens. We also have a Wiley mill in here, and that's for grinding plant samples. When they put plant samples through a mass spectrometer, which is a machine that measures different nutrients in a plant, they can use this machine then to make the samples that they need to go through the mass spectrometer. We also have here this big machine behind me, the big square one. That's what they call an elutriator. And what we're able to do with that is be able to wash roots, plants, so we can get the weight of just the plant without any dirt or soil material attached to it. And it also is used to separate nematodes out of soil for those that do nematode research. They're microscopic, look like worms, so they're parasitic to most plants, and they're able to separate those out of the soil. Otherwise it'd be very tedious to try to get those out of the soil. At the end of the hall, you'll see the big blue tank there. That's our RO water system, which stands for reverse osmosis. And it's purified city water that goes through several filters. And by the time it comes out to these gray pipes, you'll see along the wall, these big gray pipes. Each greenhouse has an RO system in it. So the researcher has the ability to choose between RO water or city water. One thing we do tell the researchers though is if you use RO, you'll have to keep an eye on your fertilization because the purified water won't have any of those micronutrients that you'll find in city water that the plants will use. So if you're using an RO water, you have to do consistent fertilization tests or you'll start seeing your plants show deficiencies in one of their nutrients. And we're gonna head out this door here and go over to the irrigated side. So this area out here behind me, if you saw there on that facilities map, was our 2 acres of irrigated section. These 2 here that are plowed up, that was a fenugreek research that was terminated this spring, so that's why there's nothing there but some weeds right now. Over here on this side we have some research done by botany in these 2 plots here. And sitting in the center of the field there's our weather station. So we're able to get weather here at the field instead of having to rely on the weather station out at the airport. It's quite a bit different. I mean, from the airport to this area here. This is a research project in conjunction with Kansas State University, and twice a year they send one of their people out to make sure the machine's working right. They do have field cameras. We can measure precipitation, wind speed, temperature, pretty much everything you see on the NOAA websites, barometric pressure. We can get all that information right here at the field, and that helps the researchers as well when they do their publications to get an accurate assessment of the field conditions here at our site versus what you see out in the airport. Yes?
Do you happen to put those results online?
We don't publish or put online what the results of the weather station are. It's more of people or researchers that ask for that information. We can download that information for them. But it's it uses up so much space on the computer that it gets put on back hard drives until they need that information.
Why don't you use natural fertilizer from the animals?
It depends on what the researcher wants to happen with their plants. Over here on the back side of the fence is our acres, which is our student farm, and all their fertilization is done through composting, which is the natural fertilizer. Some are looking for, say, phosphorus deficiencies, so you wouldn't want to put just a general fertilizer down. You know, you have to tailor it specifically to what the researcher is looking for in the plant. If they're looking for nitrogen deficiency, say, it's hard to scale what natural fertilizers have versus the synthetic fertilizers. Behind you here we have pallets of soil, various different types, again depending on what the researcher's needs are. We have the ability here to make special mixes. We bring in bulk sand and bulk amounts of just regular potting soil. So we can make our own mix here, or you can get some ordered in and it's palletized, sits out here. We just don't have enough room inside to bring it all in. So we do have the ability to make different mixes depending on what the researcher wants. Over here on this pile that has all this corn on top of it here, this is our disposal pile. So all the research, once the researchers are done with their projects, they can empty out their potting soil into this mound here. This gets incorporated out into the fields to help build a better soil profile. We ask though that the researchers, anybody that puts soil out there, you know, if they used, is it an herbicide study or something that may have a chemical or something in it, we don't let them put that in the recycle. We autoclave that soil, and then after it's autoclaved, then it can go into the recycle. So it's pretty safe soil. We get it spread out and it helps to build our soil profile. The wind out here, once we till, will take off soil very quickly once it's tilled, unless it's planted. So it's a consistent, or we constantly are adding stuff to the soils here to keep it a good growing medium for the researchers. This tunnel here behind me, it's basically it's called a rainout shelter. It's not a true high tunnel, but he's using this tunnel here to keep all the moisture off of his plants. He does have it here on the dryland side, and the measurements that he's taken are real specific to the amount of moisture that he has in the soil. So he built this tunnel here to help keep the moisture off of his research, so he can get accurate assessment of moisture in the soil. You'll be seeing the presentations out here on this south side. This is the 1 acre dryland side here. So you'll see here in about an hour or so when the presentations, they'll talk more about stuff here on this side.